Hello and welcome back to Assembly Language Programming AT89C51. In this video, I'll explain how to interface DC motor using KEIL and PROTEUS. But at first, let us write the programs. For that, go to Project, click on New Microvision Project, and give some name to the project as I'll give as motor. Click on Save. So now click on Add Now, plus sign, and click on AT89C51. Click OK. No. Now go to File, Create New. Now we'll write the program. So to write the program, we have to include a library called #include register 51.h. This is a header file we have to include. Next is we have to take two polarities because the DC motor has two polarities, positive and negative, and motor moves in clockwise and anti-clockwise direction. So we have to initialize them. So S bit P for positive polarity and take as P is equal to connected to port P1. P1, I connect to port 1.3 to the pin 3, 3 semicolon. Similarly, negative polarity, we need to connect N is equal to port 1.4 LT. So we have done the connection part. We have to initialize that. Then start the main program void main. So the program consists of the rotation of the motor clockwise and anti-clockwise. So for that we can write unsigned, take an unsigned integer I. I'll tell you what is the purpose of this integer. Now initialize the both polarities with the 0 first. N is equal to 0. 0 semicolon, and then if it is true, y1, so while loop starts, you can give some space here for writing the program. So the while loop starts. So in the while loop, you give so initially the motor has to move in one direction, that is clockwise. In the clockwise direction, set P to 1 and N to 0. Okay. Now we need to do some delay for rotation. So for I, that's why I use the I is equal to 0. Semicolon, I less than some time period, suppose 20,000 milliseconds, semicolon, I plus. Next. Similarly, this is for the clockwise. Again, for anti-clockwise, P should be reversed. The polarity should be reversed. P is 0 and N should be equal to 1. And for the same delay, it moves in anti-clockwise direction. So same delay we can use. That is the loop. We can end the loop here, while loop, and then we can also end the main program. So this is simple, right? We have taken two polarities, P and N variables, and then we have connected to port 1.3 and N to 1.4. Then we have taken P, initially P and N as zeros. In the first state, we have initialized P with 1 and 0 for a time delay of from 0 to 20,000. The P will be in one state, N will be 0. And later we exchange P to 0 and to 1. That means if P1 and N0, it will be the motor will be moving in clockwise. If P0 and 1, it will be moving in anti-clockwise direction for a delay. So this is for loop is for the delay. So this is the program. So first save this file, save as motor dot c. Here you have to give extension as c dot c. Save. Now add file to the project. So click on plus sign, right click on source group 1, click on add files to source group 1 and take consider motor.c, add, close. Click on plus sign to see whether the file is being added or not. Let us check the errors if there are any errors in the program. So for that you go to project build target. So there is an error. I have written integer INTI. Again, build the target. So there are 0 errors and 0 errors. Now we have to create a hexa file here. Next step is to create a hexa file so that we can use that hexa file in the PROTEUS to run the DC motor. So for that, you click on right click on target 1 and choose options for target 1. Then go to target. Here change the frequency, crystal frequency as 11.0592. Use this crystal frequency. Click on use on chip 1. Then go to output. And here click on create hexa. So first step is you have to go to target. You have to change the crystal frequency and then click on use on chip 1. Then come to the output, click on create hexa file, then click OK. So the hexa file will be created. Okay. Now, so this part is over. Now we'll go to PROTEUS. Now let us go to PROTEUS. Click on pick devices from library. So here we choose AT89C51. Click on that and press OK. Click on this and drag it to the space. You can expand. Similarly, click on P and go for the DC motor. And then go with the simple motor simple DC motor. Okay. Click on here. And then now we have to do the connection part. So 1.3 is connected to the motor one end and go to 1.4 to other end of the okay. Now we have to upload the hexa file. For that, double click on this. Now choose the hexadecimal file. Now we have to choose the path of the hexadecimal file. We can copy it from there, or we can just click on this and select the folder. So my hexa file is in C drive. I have copied the path and then pasted it here. Now change the crystal frequency to 11.0592 megahertz. Click on OK. Now you can start the simulation. For that, click on play button. See. So for some time period is rotating in clockwise, and after some time period is rotating in anti-clockwise direction. I hope you all understood how to interface DC motor using KEIL and PROTEUS. Thank you.